Hi there, I'm Dave from DPS Instruments Europe, and I brought a companion along with us today. This little thing goes with you wherever you want. In this episode, we're going to be discussing a configuration that's called PermaGas+Sulfur. Maybe you caught another episode of just the permanent gas. This does all of those things. The permanent gas is hydrogen, oxygen, nitrogen, carbon monoxide, carbon dioxide. It also does the C1 through C6 hydrocarbons at the same time. But we've added another detector, we've added another column, and simultaneously we're analyzing the light sulfur compounds. Hydrogen sulfide, carbonyl sulfide, dimethyl disulfide, methyl mercaptan, ethyl mercaptan, and a whole bunch of other ones, all at the same time. Let's look and see what we have inside. Okay, here's our PermaGas+Sulfur configuration up on the bench. Let's look at the parts inside. Color touchscreen, computer interface. We have two detectors, the HID for the permanent gases and the PID for the sulfur compounds. Inside here is our gas sample valve, and in the column oven we have our 3 columns. To get going, simply connect the gas, and in this case we're actually using one of our small high pressure refillable cylinders. Enough helium in here to last for about a week of operation between refills. So simply plug it in, turn on the power switch, you're ready to go. Let's explain how this works. We have 2 columns in series, a molecular sieve and a silica gel. Carrier gas passes through the molecular sieve, through the silica gel, off to the detector when the sample is being loaded. However, when we inject, we put the sample onto the silica gel first. What happens there is at that starting temperature, the C2, C3, C4 compounds stick here, but the permanent gases flow right through over to the mole sieve and they're separated. The hydrogen, oxygen, nitrogen, methane, CO separate very nicely. When that's finished, we switch the gas back again. Mole sieve first, then the silica gel. Heat up the oven to drive the compounds off the silica gel. This keeps the mole sieve nice and clean, because if we get these heavy compounds on the mole sieve, they're just going to stick there and cover the pores and the surface, and the resolution of this column is going to diminish. So in this very unique configuration of 2 columns in series, 1 common carrier gas where we can have the carrier gas go through this one first and then this one, or through this one first and then this one, we have this completely covered and almost a maintenance-free system. In our PermaGas+Sulfur configuration, we've added a second detector and a 3rd column. Okay, we still have our molecular sieve doing the permanent gases, and we have the silica gel doing the C1 through C6. But when we inject the sample, we split it. Half of it goes to the silica gel, half of it goes to the 3rd column to detect sulfur compounds. Hydrogen sulfide, carbonyl sulfide, methyl and ethyl mercaptan, dimethyl disulfide, and more. So, 1 column is doing permanent gases, 1 column is doing small hydrocarbons, and the 3rd column is doing the sulfur compounds, all simultaneously. 1 carrier gas, 3 columns, 2 chromatograms, covering this whole range of compounds in 1 simple injection. When the GC boots up, Windows boots up first, and then the DPS software. Once the GC boots up, the PermaGas method automatically loads. This is our method page. A method consists of several parts: the oven temperature program, the timeline, which is rotating the valve, the detectors, and of course the carrier gas. Each of these color-coded buttons will get you to the editor, or you can also access them through our quick navigation bar on the right. For example, the oven temperature program, just touch this button. This is our temperature program. We're starting at 60 and holding there for 4 minutes. This is the time when we're allowing the mole sieve column to separate those light permanent gases: hydrogen, oxygen, nitrogen, methane, and CO. Once those are separated, we rotate the valve back and start the temperature ramp to drive the light hydrocarbons off the silica gel column. The timeline is the valve. It starts at a half a minute and continues for 3 minutes before it rotates back. On the detector page, the first tab is everything to do with the PID. And on the second tab, we have everything to do with the HID. You can toggle back and forth to check the temperatures and pressures. Last, we have the pressure program, which is starting and ending at the same pressure, so it's a constant pressure throughout. If we toggle the run page, we see a graphical representation of the entire method. The top is the oven temperature program, the pressure program, and the bottom is the timed event, and this one is the rotating of the valve. We can see that our GC is ready, so we can start a run by simply hitting the start button. The chromatograms pull up. First we're going to see the permanent gases, then we're going to see the light hydrocarbons, and on the bottom chromatogram is going to be the sulfur compounds. At any time you can toggle back and look at the run page, for example. Here is our run progress bar, and when it hits an access, that function is going to occur. You probably just heard the valve rotate as it crossed this axis. When it crossed the other end of the bar, the valve will rotate back. Using our quick navigation, we can look at what's happening in the oven. Here's our oven temperature, the valve set point, carrier gas pressure. This is how long the run has been moving along. We could look at the temperature program or the detector page. We go back to our run page by simply toggling. We can look at our chromatograms again, or go back and forth. Very simple, very easy, the DPS software. So this is our PermaGas+Sulfur configuration. Everything is included in here. 2 detectors, 3 columns, switching valve. Turn it on, hit the start button, you're ready to go. Analyzing permanent gas compounds, light hydrocarbons, and sulfur compounds all simultaneously. This companion goes with you anywhere. Once again, I'm Dave. On behalf of DPS Instruments Europe, I thank you.